Hi everyone, today's lesson is on slope and y-intercept, and our learning goal is to learn to graph linear equations using the slope and the y-intercept. Now there's two components to your foldable. One is 2 pages and it's double-sided so that you can fold one inside of the other the long way like a hot dog, right, and paste it into your notebook. So what you should have is kind of this folded piece that looks like a long rectangle, but on the inside there's more information that we're going to use. So make sure that you're folding that correctly so that when you open it up you can see what's inside. The second piece you're just going to paste flat to your notebook paper to the side, and that's going to be kind of an example of how we graph. So there's a lot of notes for today. Try to follow along as best as you can, okay? The first thing we're going to look at really is that we've pasted this component of our notes to the side, and so for me specifically I need to be able to rotate and write on my own. So I'm going to take those components and I'm going to rotate so that I can work vertically and I don't have to worry about having to flip my whole page. But just so you know, you should have these pasted horizontally in your notebook. Okay? All right. So what you should be kind of looking at is your template, and each page has kind of this window, right? So we're going to start on the left-hand side and then we'll work our way over to what we need for today. So the first tab that we're going to go under is graphing. It says I can find the slope from graphing. So if you flip up your graphing tab, what you should see underneath is this page that has the slope equals m. And it says m is equal to the rise over the run, or y1, y prime over x prime. Both of these values are kind of interesting because when we look at them, we think about the change in y and the change in x. So for example, if I have a point on the y-axis that is at a height of 2, there we go, and another point kind of crossing at the coordinate 2, 5. When I think about the rise and the run, first I want to think about how many spaces up or down do I have to go to get from my first coordinate to my second coordinate. So first I'm going to talk about the rise, and the rise can be up or down. If it's up, it is positive. If it's down, it's negative, right? So in this case, I'm going to go up first. I'm going to go 1, 2, 3 spaces up. So my rise is going to be a positive 3. And then I'm going to think about my run. And the run is the horizontal change. And again, it can be positive or negative. If you go to the right, it's positive. If you go to the left, it's negative. In this case, I'm going to the right, positive 1, positive 2. So when I think about my slope being rise over run, my slope here is 3 over 2. Right? If I scroll down a little, it says check your slope. If the slope is positive, it's always going to go in this kind of upward direction, like if you were about to climb up a hill. But if it's negative, it's going to go down from left to right, like you were sliding down like on a sled. So when you think about your slope, always think about going from left to right. And if it's going up, it's positive. If it's going down, it's negative. Okay? The next piece of our notes that we're going to go over is the flap that says table on it. You're going to find the slope using a table. And this is going to just show you how to use that data to kind of similarly use the equation that we've already looked at, the change in y over the change in x. So we're looking at some division, right? In particular, I want to know what's changing between y values and what's changing between x values. So I need to pick two coordinate points. It can be any two. I'm going to pick the first one and then maybe this one over here. And I need to determine the change. When you think about a value changing, one of the most common ways we do that is through subtraction, through finding the difference of something. So I'm going to start with my 10 because that's a y value in the second coordinate that I selected. So I'm going to start with the 10, and if I need to know how the y values from 10 changes from my other coordinate, that's a y value of a negative 2. So I'm going from 10 to negative 2. And remember, we talked about doing subtraction so that we can find the change. So I'm using subtraction here as well. Next, I need to do the x values in the same order, right? So because I use the 10 first, I'm going to use the 5 first. And I'm going to find the change in the x values from the 5 and then to the negative 1. So see how my equation models this description up here? I'm looking for the change in y over the change in x. I think we've talked about before that when you subtract a negative number, it makes a positive integer. So I'm just going to rewrite this so it makes a little more sense for you guys. 10 plus 2 over 5 plus 1 is going to equal 12 over 6. Now, this is an improper fraction and may look odd to some of you. You can certainly write this as a value of 2. But just know that when you're looking at a slope value and you need to graph with it, you always kind of want it in fraction form. So if you do write it as 2, eventually you may want to think about it as 2 over 1. The third way we're going to look at slope is through ordered pairs, just by using two specific ordered pairs. Again, all of these methods are very similar, but we're finding the information from a different place. So what the ordered pair formula tells us is that the change in y over the change in x is actually y1 minus y2 over x1 minus x2. And I'm just using the 1s and the 2s to remind you that this first x and y should come from the same ordered pair, as well as the second x and y. These should also come from the same ordered pair. So when you have your coordinate points, you kind of turn them sideways and you think to yourself, okay, x is on the bottom, y is on the top, but they have to go together, right? One coordinate pair goes first, then the second coordinate pair. It also says, remember, y goes first. It always goes on top because we're always talking about rise over run. We're always talking about vertical change over horizontal change. And this is the opposite of graphing your coordinate pairs, because when you graph, you always graph your x value first. So it could be a little confusing, but we just need to stick with it, right? So there's an example here. It says, find the slope of the line that passes through the points 2, negative 3, and 5, negative 6. So remember, we talked about the first coordinate needs to go vertically, and the second coordinate needs to go vertically. And we know that y goes over x. So we're going to take the y value from the first coordinate, which is negative 3, minus the y value of the second coordinate, which is negative 6. And then the x value of the first coordinate, which is 2, minus the x value from the second, which is 5. So we can rewrite this, negative 3 plus 6 over 2, over 2 minus 5. Negative 3 plus 6 is positive 3. 2 minus 5 is negative 3. So again, we end up with this fractional value that we can simplify. 3 over negative 3 is actually equal to negative 1. At some point, we may want to look at that as a fraction again, but I think it's worth simplifying in terms of solving our equations either way. The last way we're going to look at slope is just in its equation form, which is y equals mx plus b. Whenever you see an equation like this, the m represents your slope, and the y-intercept is equal to b. We're going to talk a little more about y-intercept in just a minute, but just so that you have an idea of how all this works. When it says find the slope in the equation, it's literally just asking you to look and think to yourself, where would that m be? Y equals mx plus b, so my m is -2. Y equals mx plus b, my m is 1/4. Y equals mx plus b, my m is invisible here, but what that means is that it's equal to 1 because I have 1x. So it's pretty straightforward to look at those equations and just see, oh, there's where the m is. There are going to be opportunities where the equation doesn't have the m right there, or in particular that it's not in the correct form to represent y equals mx plus b, and we'll have to change that form to make it work for us. So I'm just going to remove this so that we can take a second and work on the rest of our notes, the second half of our notes, which is this component here, which says graph the line expressed by the following equation. So y equals 3/5 x plus 2. If you look at that specifically, you should think to yourself, the slope here is 3/5, and the y-intercept is 2. I know we haven't talked too much about y-intercept, but the y-intercept basically says if you are on the y-axis, which is your vertical axis, the intercept tells you where your line crosses the y-axis. So in this case, it's at +1, 2, so I place my y-intercept at +2. Given the slope, I can say what my rise is and my run is. So my numerator, 3, is my rise, so I'm going to go up, 1, 2, 3. My denominator, 5, is my run, so I'm going to go to the right, 1, 2, 3, 4, 5. And I'm going to plot a second point. As soon as I have 2 points, my line can be drawn because I only need 2 points to draw a line. So I want to make sure that my line goes directly through those 2 points, and I know that I'm correct. I can always check my answer by picking a random coordinate point on my graph. I can pick this point that I used for the second set of the slope, maybe for just a minute. And when I look at it, I can see that this is point +5, +5. So 5, 5 should be a solution to my equation. So what I can do is plug that in. Y equals 3/5 x plus 2. If y is 5 and x is 5, is my equation true? Well, 3/5 times x is the same as 3/5 times 5/1, so I get 15/5, which is just 3. So 5 equals 3 plus 2. That's true. So I must have graphed my line in the correct location. I could also find a second point if I wanted to check, like this one over here. Anything that's on like a nice grid line, that's crossing a nice grid line, will work to check a point. Your proof for today, I've printed it a little small, but you don't have to print this graph. All you need to do is give me what is the slope of y equals 1/2 x plus 3, what is the y-intercept, and draw yourself a simple graph. Just graph that line using 2 points. This is going to be good practice for our class.